All right, so in this video, we are going to learn about argument of a complex number, and we will see one more representation of complex numbers on complex plane, which will eventually lead to the polar form of complex numbers. All right, so I'm going to change the background to the graphical background. So first, we will see what is the argument of a complex number. So let me draw the real and imaginary axis. Okay. So this is the real axis and this is the imaginary axis. Now we have seen that if we have a complex number z, which is a plus bi, where a is the real part and b is the imaginary part, we can actually represent it on a complex plane. Let's say it is somewhere over here. Okay, this is z. So if I know the values of a and b, that would make the position of this complex number fixed on the complex plane, right? So for instance, let's say, okay, so over here, let's say that we know that the value of a is 3 and value of b is also 3. So I just have to move 3 units on the real axis and 3 units on the imaginary axis, and that would give me the position of my complex number, right? So if I know the value of a and b, I know the position of my complex number in the complex plane. So this is the first way of representing a complex number on the complex plane. Now there is one more way. There is another way of representing a complex number on the complex plane. Let's see what is that other way. Let's just say I am connecting this complex number with the origin. Okay. And now I don't know what are the values of a and b. Is there any other way that can fix this complex number in the complex plane? Yes. What if I know this angle? How much is this angle? Starting from the real axis, I move in the counterclockwise direction. And let's say that this angle is theta. Theta is a Greek alphabet. Now let's say I know the value of this angle. Would it fix the position of the complex number? No, it won't. Just by knowing the value of the angle, so let's say that this angle is 60 degrees. Okay, let's say that wherever my complex number is, it is making the angle of 60 degrees with the real axis. Would it fix its position? No. See, it could be over here. See, it could be over here, right? It could be over here. It could be over here. It could be over here. All these points would be making the angle of 60 degrees with the real axis, right? Any point on this segment, all the points are making the angle of 60 degrees with the real axis. So just by knowing the angle, it will not give me enough information about the location of my complex number. But what if I also know its distance? What if I also know its distance from the origin? Let's say the distance is this much. Okay, I know this length, how much far away my complex number is from the origin. So if I know these two information, if I know these two things, that what is the angle my complex number is making from the real axis and how much far away it is from the origin, then I would be able to fix the position or the location of the complex number, right? I hope you got it. So as I mentioned, this is the second way to represent or to plot a complex number on the complex plane. So let's just do this. Let's say that this is my complex number and it is making an angle of theta with the origin. Oh, not 60. I meant to write theta. So it is making the angle of theta when I move in the anti-clockwise direction, counterclockwise direction from the real axis. And let's say that this distance that we are interested in, this distance is given by r. Okay, this distance is given by r. So if we know the values of this r and theta, we will be able to represent the complex number on the complex plane. Okay. So let's see how we can find out the values of r and theta. So now what I'm gonna do is I'm gonna write my complex number in terms of r and theta. Okay. And then from r and theta, I will write it in the form of a and b, because a and b are two things which will be known to us. Then from a and b, we will move to r and theta. All right, so let's get started. I'm going to complete this triangle. It always comes down to Pythagorean theorem. So this completes the triangle. All right, now, and this was my complex number, like the coordinates of this point are a comma b, which means that this particular length is, this is b units, and this particular thing is a units. Right? Now, time to recall the trigonometric ratios. Let's see if you guys remember the trigonometric ratios. And I'm just going to change the background to the normal one. All right. Now, if you look at this, this is the right triangle. What is the value of sine theta in this triangle? Sine theta is given by opposite over hypotenuse. So this is nothing but b over r. And what will be the value of cos theta? Cosine of theta. So cos theta is given by base over hypotenuse. So it's nothing but a over r. So I'm going to cross multiply them. This means that cross multiply. So this will give me r sine theta is equal to b. Again, here also cross multiply. So this gives me r cos theta is equal to a. So now see, I have the values of a and b in terms of r and theta only. So what I'm going to do is I'm going to substitute the values of a and b in this particular form. Okay, so I know that z is equal to a plus bi, and I've just found out the values of a and b, which I'm going to substitute over here. Value of a is r cos theta, and value of b is r sine theta, and then I is there. I can take out r, and I'll be left with cos theta plus I sine theta. And this is nothing but your polar form of a complex number. Let me highlight it. Z equals R cos theta plus I sin theta is called the polar form of a complex number. This is called the polar form of a complex number. So if you have, okay, and one more thing, this is called the rectangular form. This is called the rectangular form of a complex number. So we can represent a complex number in two ways. First is in rectangular form, second is in polar form. And what is the argument of a complex number? Argument is nothing but this angle theta. Okay. The angle which the complex number is making from the real axis is nothing but your argument. And how can you find out the value of theta if you want to find it out? So if you see, what will be the value of tangent of theta? Tangent of theta is given by opposite over base. So opposite is B and base is A. And so that means theta will be tan inverse of B over A. Or you can say arctan B over A. So this is how you can find out the value of theta. And how will you find out the value of R? R is what? What is R? Look at here, look at this diagram. R is nothing but the modulus of this complex number. And we have already done in the previous video. What is the modulus? Yes, it's the distance of this complex number from the origin. And if you apply the Pythagorean theorem in this triangle, so value of R is nothing but square root of A squared plus B squared. So now, see, if you guys know the values of A and B, right? If the complex number is given in the rectangular form, A plus BI, right? If you know the values of A and B, then from, right, if the rectangular form is known to you, then from rectangular form, you can go to the polar form. How will you go to the polar form? See, this is the polar form. You can find out the value of R by doing square root of A squared plus B squared. And you can find out the value of theta by doing tan inverse of B by A, right? And what if the values of R and theta are given to you? Then from R and theta, how will you go back to the rectangular form? So if the polar form is given to you, R and theta are given to you, then how will you go back to the rectangular form? It's very simple. So you just, value of B is R sin theta and value of A is R cos theta. So if you have to do the reverse thing, let's say R is given to us and theta is given to us. So what will be the value of A? A will be nothing but R cos theta, and value of B will be nothing but R sin theta. So this is how you can go from rectangular form to polar form, and this is how you can go from polar to rectangular form.